Hi everyone, welcome to lesson 27. We're continuing to learn about factoring, and this lesson is kind of a continuation of the one before it in that we're still factoring and we're still factoring trinomials. However, it might feel pretty different because even though we're still factoring trinomials, polynomials with three terms, now we get to see trinomials where a is not equal to 1. So when we say that, what we mean is the leading coefficient a in front of x squared, ax squared plus bx plus c, that a will no longer be 1. So that's going to complicate things because when we FOIL, when we distribute, we can't just start with x times x equals x squared. There's going to be this other number that comes into play. So our methods will have to adjust a little bit. Okay, now what I have written up here is to factor a trinomial, ax squared plus bx plus c, there are two methods available. Now, I have since learned that there are more than two methods available. Some students have learned other ways from other algebra teachers or other sources, which is fine. I will be focusing on just two methods, the ones that are covered in our book and the ones that I'm used to using. But just know that there are other methods, and if you're wondering about them, I'd be happy to show you or talk to you more individually. But I just felt like showing you 3 or 4 methods would get a little confusing. So we're going to stick to 2. Here they are. The first one is called trial and error or FOIL. Okay, we're kind of using FOIL in reverse. When I was a student, this one was called guess and check. I think we prefer to say trial and error because nobody likes to feel like they're guessing in a math problem, although it might feel like that a little bit. So trial, that's sort of the guessing part. We're going to try different things. Error, I mean, it's inherent in the name. You're going to try things, and then if they're wrong, you'll try something else. We're going to kind of narrow down our possibilities that way. And that's what example 1 will be going over. Then this other method is called the AC method. That's the one where we'll be using grouping. So when we get to that method, we're going to be essentially changing our trinomials from having 3 terms into 4 terms. Once we get them to turn into polynomials with 4 terms, then we'll be able to fall back on factoring by grouping, which is something that we have already learned. Now you might be wondering, why are we learning 2 ways? Why can't we just do 1 way? I think they each have their benefits. And there will be some problems where one method will work better than the other. The reality is either one is fine for any problem. When we get to the AC method, we're going to be multiplying A times C, the first times the last term. When those numbers are very large, that's when I would not use that method. Okay, so it is more systematic and some students will prefer the AC method, which is why I'm about to show you trial and error first. All right, because what I used to find is when I would teach this, I would teach the AC method first, and then I feel like students would tune out by the time we got to trial and error. All right, that's enough intro. Let's do an example here. Okay, example 1. We're going to use this trial and error method, otherwise known as FOIL. So here we go. We're factoring 2x squared plus 9x plus 4. Now, most recently, we were learning about factoring trinomials where there was not a number in front of the x squared. So you might instinctively be looking at this and saying, okay, wait, do I have to find numbers that multiply to 4 and add to 9? How's that going to work? There's no such thing. The answer is no, you're not going to do that. Now this 2, that changes everything, okay? So instead of almost ignoring that first term like we were doing before, now we do need to pay attention to it. So here's how we're going to start. We know that when we factor a trinomial, the answer will still have 2 binomials. Remember, trinomial has 3 terms. Tri means 3, like triangle. Bi means 2, like bicycle, has 2 wheels, right? So we have 2 binomials that will be our final answer. So now we're going to kind of, in a way, fill in the blank. Now these first 2 terms, you might be used to just writing x times x here. but that's not really going to cut it because x times x, when we FOIL, that would be x squared, but we need 2x squared. So that's why we need these two coefficients. They can't both be 1. 1 times 1, that's not going to work. We need numbers that multiply to 2. So I'm going to have us start with 2x times x. So 2x times x, that's the 2x squared. That's the first part of FOIL. And now we're going to skip ahead and focus on the last term. So see this middle term of 9x, we're going to sort of ignore it temporarily. Okay, so start with the first terms, multiplying to 2x squared. Now let's focus on the last terms, needing to multiply to 4. So this is where we're going to run through some options. So this is we're getting to the trial part, because you can see there's many combinations that we need to consider. What are some factors of 4? Well, if I make a list of factors of 4, 2 times 2 might come to your mind. 1 times 4. And now I am going to list 4 times 1 as a separate option, because now that we have this 2x in play, now it will matter whether I put a 1 here and a 4 here, or a 4 here and a 1 here. So I do need to consider both of those. Okay, let me kind of redo that table. That's just a little sloppy. But essentially what I'm trying to do is make a list of factors of 4. Okay, and let me do it in the order that I showed you last time. So 1 times 4, 2 times 2, 3, and then 4 times 1. So I am going to list them kind of in order, but that's what's being given to you here. The order isn't really important as long as you have all the options there. So here comes the trial part, or the guessing part, I guess. And then we're going to check and see if we get any errors. If we get an error, we'll try again. All right, so here are our possible combinations. We're kind of filling in these blanks with these different possibilities. Okay, so in no particular order, our first possible combination is right here. We have the 2x and the x in those first spots, and then here in red, we have the +2 and the +2. How will we know if we got it? Well, let's check using FOIL. So 2x times x, that's 2x squared. Then my outside terms, 2x times 2, that's 4x. Then my inside terms, 2 times x, that's 2x. And then my last two terms, 2 times 2 is 4. So did we get it? Well, take a look. We have the 2x squared. That matches the original problem. At the end, we have the +4. That matches the original problem. So what we really need to check is those middle terms. Now, when we combine those middle terms, +4x and +2x, that adds up to +6x. So our final answer when we're checking is 2x squared +6x +4. So good try. That was a trial, but no, that one doesn't work. Because what we wanted for our final answer is we wanted 2x squared +9x +4, and instead we got 6x. Okay, so good try, but no. So I'll just draw a line through this to say no. I'm not going to erase it or scribble it out because we want to keep track of what we're trying. Okay, now let's move on to the next combination. So we tried the 2 times 2 option. Cross that out. Remember, we're filling in the blank so that our last two terms multiply to 4. We tried 2 times 2 is 4. That didn't result in the trinomial that we wanted. Now let's try the next combination. So we'll try putting a +1 and a +4. So we're trying 2x + 1 times x + 4. So once again, let's check this by doing that FOIL process. 2x times x, that's 2x squared. 2x times 4, that's 8x. 1 times x is 1x, or you can just write x. And then 1 times 4 is 4. So I have 2x squared plus 8x plus x, or 1x, and then plus 4. When I combine those middle terms, positive 8x plus 1x is positive 9x. Okay, so that's actually the one. This is our answer. Because C, when we checked it, we got the exact trinomial we were looking for, 2x squared plus 9x plus 4. So this is going to be it, which means I don't even really need to check that last one. But just for the sake of being thorough, I will, just to make sure you can see why that one would not work. Okay, so even though we technically found the answer, here's why the next one would not work. If we check the next combination, which is 2x plus 4 and x plus 1. So see how the 4 and the 1 kind of switch places. We're checking this combination now. 2x times x is 2x squared. Outside terms, 2x times 1 is 2x. Then my inside terms, 4 times x is 4x. And then 4 times 1 is 4. When I add those middle terms together, 2x plus 4x, that's 6x for my middle term. So 2x squared plus 6x plus 4. That's actually the same answer as my first try gave me, which might seem strange. I won't go into why that is right now, but it doesn't work because once again, it doesn't match what we were going for in our original problem. Okay, so our final answer is 2x plus 1 in parentheses times x plus 4 in parentheses. And I could check by doing FOIL, which I pretty much already did. 2x squared plus 8x plus 1x plus 4. When I add the middle terms, 8 plus 1, that adds up to 9x. Okay, so remember how we were kind of ignoring the 9x that I said at the beginning? We focused on the first term, we focused on the last term, didn't worry about the middle term. Here's where you check to see if your middle term is actually working out for you. Okay, so that's kind of the outside and inside terms being added together. Okay, so once again, when we check using FOIL, it's that outside and inside terms that add up to 9x. All right, so I know that seems like a lot. If you've never seen this before, I would be surprised if this made perfect sense right away. Like everything we do, it's gonna take some practice. Our final answer again is 2x plus 1 times x plus 4. We checked by using FOIL. And again, the way we got there is it might feel like guessing, but I hope you can see it's very systematic as well, meaning there's kind of a method to it. It's not random guessing. So first we filled in our first two terms, 2x times x is 2x squared. Then we skipped ahead to look at possible factors of the last term, so factors of 4. We tried 2 times 2, we tried 1 times 4, and 4 times 1. The one that worked was 1 times 4. So we put the 1 with the 2x and the 4 with the x. All right, good. So that's one example of trial and error. I'm now going to do one more of trial and error, and then we'll take a look at the AC method that I mentioned. Okay, so let's go to example 2 on the next slide. 2x squared plus 7x plus 6. So our directions, we're going to factor using trial and error, otherwise known as FOIL. Okay, so there's a nice blank page in front of us, not as many hints along the way. So the first thing we're going to do is let's set up some parentheses like we did before. So it's kind of our binomial, our two binomials. Our first two terms need to multiply to our first term in our trinomial, which once again is 2x squared. So just like last time, I will start with 2x times x. The order doesn't matter, just pick something and go with it. And now our last two terms need to multiply to 6. So my factors of 6, I could do 1 times 6. I could do 2 times 3. I could do 3 times 2. I could do 6 times 1. So those are all the different combinations of factors of 6. Again, the order doesn't matter as long as you have everything covered. All right, so what I'm going to do now is try plugging in these numbers, kind of in that fill in the blank process that we had seen before. Okay, so 2x plus something and x plus something, and here's what I'm going to try as factors of 6. So let's we'll just kind of follow this order, I guess. I'll put +1 and then +6. So 2x plus 1 and x plus 6. Let's check it. Okay, so when I check, 2x times x, 2x squared, plus my outside terms, 2x times 6, 12x. That's already kind of not a good sign, because don't I need my middle terms to add up to 7x? And if this is already too big, this one's not going to work. But I'll keep going. 1 times x is 1x, or x, and then 1 times 6 is 6. When I combine those middle terms, 2x squared, I get, when I combine those middle terms, 2x plus 1x is going to be 13x in the middle. So 2x squared plus 13x plus 6. So I'm looking for that 7x to be in the middle term. It's not working. So good try, but no, that didn't work. Let's move on to the next possibility in my list here. So the next possibility I have is 2 times 3. So I'll do 2x and x. This time I'll try +2 and +3. +2 and +3. Okay. I'd like to point something out right now before I go through the whole checking process. A little tip: if any of your tries involves a factor where there's a GCF, don't try it. Here's what I mean. So go back to the original problem up here, 2x squared plus 7x plus 6. There is no GCF, okay? We couldn't factor out a 2 from every term in this problem or in the problem before it. So that was not an option. There's no GCF. However, take a look at what I just wrote here. 2x plus 2 times x plus 3. The 2x plus 2, there's a 2 in common here. Okay, so that's not a good sign. I'm seeing a GCF where there should not be one. So if your original problem did not have a GCF, a greatest common factor, then you should not be seeing a GCF in any of your trials or your guesses. So I'm just going to cross this out right away. Okay, I do not want my answer to have a 2 as a GCF, because again, that was not the case in the original problem. So that's a sort of a shortcut way of crossing that out. All right, let's see. What am I going to do next here? I'm going to go out of order just so I can save the one that works for last, because I already know the answer. So going out of order here, if I try the 6 times 1 option, 2x and x, if I put a +6 with the 2x and then a +1 with the x, it's the same situation where, look, I have a greatest common factor right here between the 2x and the 6. There's a 2 in common. Again, for the same reason as before, I do not want that in my answer. And also it's just a clue that it's not going to work. So I'm kind of bypassing the FOIL part of this. I'm not even doing the full check because I can already tell it's not going to work, okay? Because there's a 2 in common in this factor right here, the 2x plus 6. And there, again, there was no 2 in common in the original problem. So that's a clue that this won't work. Now, if I've just lost you on this whole GCF commentary, that's okay. You just check it. I mean, check it using FOIL. So maybe just to backpedal a little bit, if we did check these, neither of them would work, okay? So back to the second one we tried, 2x plus 2, x plus 3. If I were to FOIL there, I'd get 2x squared plus 6x plus 2x plus 6. So the 6x plus 2x add up to 8x, which is close to what we want, but it's not equal to 7x. And then for this one that we just tried, oops. If I were to FOIL 2x plus 6 and x plus 1, I'd get 2x squared plus 2x plus 6x plus 6 if I FOILed. And actually, look, it's the same answer. For the same reasons for both, when we FOIL, we're not getting that 7x that we're looking for. Okay, which brings us to our last possibility. I've saved it for last. This 3 times 2 combination will be what will actually work. Since I have run out of space, I'm going to switch over to another blank screen to to write our answer and to really check it. Okay, so I'm switching over for a moment here. Okay. So just to do a little bit of rewriting, 2x squared plus 7x plus 6 is what we're trying to factor. We're trying that, let's see, what are we trying? We're trying the 3 times 2 combination. So what we're doing now, trial and error, we have 2x and x at the beginning of our parentheses. We're filling in the blank. What we're going to fill in is next to the 2x, we'll write plus 3. And next to the x, we'll write plus 2. So we're going to check 2x plus 3 times x plus 2. So here's what the check looks like. And again, when I check, I'm doing that FOIL process. So reminder, our first two terms, 2x times x, we already knew that those would multiply to 2x squared. Our last two terms, we already knew that those would multiply to 6, right? We chose them that way. So really the one that we're now paying extra close attention to is that middle term of plus 7x. That's the outside and inside terms that we're about to check. So let's check it. 2x times x, 2x squared, we knew that. Plus outside terms, 2x times 2, that's 4x. And then my inside terms, 3 times x, that's 3x. Finally, my last two terms, 3 times 2, there's the 6. And again, we already knew to expect the 2x squared. We already knew to expect the 6. That was coming up every single time we were checking our possibilities. But again, what we're really paying attention to is these middle terms. And yes, they do add up to 7x. So when I complete my check here, I am getting 2x squared plus 7x plus 6. Okay, so that's an indication that my answer checks out, which means here's our correct answer. So 2x plus 3 times x plus 2. Okay, so with factoring like this, what will happen is sometimes when you do trial and error, you're going to get it on the first try, which is always fun when that happens. It doesn't always take so many tries that we're doing together. However, I will say right now, it's important that you can show your work in some way. Okay, so even if you're keeping it all in your head, and some of you will be able to really do this a lot in your head, you're kind of running through your possibilities in your mind. You need to be able to write that out somehow. So at the very least, when you factor a trinomial like this, you need to show the check process. And that goes for our written homework as well as on a test. If all you do is write the answer with no work at all, even if you say you're doing it in your head, I believe you, I still need to see written out what it is that you're doing in your head, okay? Which I know takes away the fun of doing something in your head. Long story short, make sure you're showing your work, which you already knew. Okay, let's go on back. So we've now seen two examples using trial and error. What we're going to see next is this other method that if you're totally new to factoring, a lot of students actually prefer, at least at first, prefer using this other method called the AC method. Okay, so let's take a look at the steps here. Totally different method. Here we go. So it's called the AC method because the first thing you do is multiply A times C. A is the first coefficient, C is the last term, the constant term. Once you multiply those together, what we're going to do is make a chart kind of like how we were doing in our previous lesson where we're coming up with, okay, numbers that multiply to this thing and then add to this other thing. We're still looking for a product and a sum. It's just that this time the product isn't just C, it's A times C. But the sum will still be B. That should probably sound confusing. You'll see an example. Math always gets better with examples. All right, so we'll find two numbers with the product A times C whose sum is B. All right. Then, once you come up with those correct numbers, you're going to use those numbers to rewrite the middle term, which was bx at the beginning, as the sum or difference of two terms. In other words, you're going to split up the middle term to change your trinomial into a polynomial with 4 terms. Why would we do that? Well, the AC method actually leads to us being able to do factoring by grouping. So once we get it into 4 terms, then we can factor by grouping. So see previous lesson 25, I think. Okay, sound good? Yeah, all right, let's see an example. Here we go. Example 3, factor 2x squared plus 9x plus 4. So I'll just say right now, we're about to do the same 2 problems again. We're just going to use a different method. So we kind of already know the answers, but try to forget. All right, 2x squared plus 9x plus 4. So the first thing we're going to do is make sure we understand what's A, what's B, and what's C. A is 2, that's the first coefficient. B is 9, that's the second coefficient. And then C is 4, that's the third term, the constant term. So we're finding 2 numbers whose product is A times C and whose sum is B. So let's start with A times C. If we do A times C, 2 times 4, then we get 8. So suddenly we're dealing with 8, even though there's no 8 in this problem. 8 is the number we're listing factors of. All right, good, let's see. So I'm gonna click a little bit more here. So just to recap, there's A, there's C. So I'm doing A times C, which is 2 times 4, which is 8. So I need factors of 8. This is my product. My product is 8. It's another way of saying that. And then my sum is 9, right? That's that B term, right? So we want to come up with numbers that multiply to 8 and add to 9. So you can see this list, factors of 8, we have 1 times 8, 2 times 4. That's it. Which one of those combinations will add up to 9? Well, hopefully you can see it's this first one, 1 times 8. Okay, so now, instead of being done with the problem, like in our previous lesson, once we came up with those numbers, we just wrote, oh good, x plus 1, x plus 8, all done. No way, that's not happening now, okay? That's not going to result in this trinomial. It's going to be something totally different. So here's what we do with these numbers. We're going to now split up that middle term. So this 9x, you're about to see it, but this 9x is about to be split apart into 1x plus 8x. That's what we mean by split up. It's kind of the opposite of combining like terms. We're splitting apart like terms. Okay, so this is the splitting up step right here. So here's our original trinomial, 2x squared plus 9x plus 4. Here's what we did so far, A times C. So 2 times 4 was 8. We had to come up with factors of 8 that added to 9. Okay, so 2 times 4 is 8. What multiplies to 8 and adds to 9? Okay, 1 plus 8. So this is the splitting up part. So 9x is now being rewritten as 1x plus 8x. From here to the end, now we get to factor by grouping. Okay, so that made that look really fast. Okay, you're about to see the full answer, and it's printed on your notes if you already printed the PowerPoint, but I'm just going to do it in my own handwriting first, and then we'll see the fully worked out answer as well. So this is where you're going to group your terms like this, right? Once you have 4 terms. In this first group, the GCF is x, and I'm left with 2x plus 1. In my second group, 8x plus 4, my GCF is 4, and again, I'm left with 2x plus 1. Remember this, the 2x plus 1, that's in parentheses, that's my common factor now, so I get to write that first. And then sort of those leftover outside terms, x plus 4, that comes together to be my final answer. So that's how I would show the work from here to the end. This is the grouping part, okay? And let me, here, let's see how it looks here. Yeah, it's really messy. You get it, it's the same thing. Okay, so you have that typed out as well if you printed it or I just wrote it out. Okay, good. So let's just kind of recap. find two numbers with product A times C whose sum is B. So we did A times C, that was 2 times 4, which is 8. We listed factors of 8. We wanted the factors of 8 whose sum was 9. So we needed numbers that multiplied to 8 and add to 9. The problem wasn't over then. Then we went over to the 9x. And we split up that middle term. So the 9x got rewritten as 1x plus 8x. Then we had 4 terms, 2x squared plus 1x plus 8x plus 4. Now we did not combine those terms. We left them separate so that we could do factoring by grouping for the rest of the problem. Okay, so let's try one on our own or without so much help. Okay, next problem. This is example 4. Factor using the AC method. Okay, so let's see if we can remember those steps. So step 1 said, find two numbers with product A times C. So A times C, whose sum is B. Okay, so let's do A times C. So A times C, that would be 2 times 6, which is 12. All right, so this is my product. So I want numbers whose product is 12. I want factors of 12, in other words. And I want them to add up or to have a sum of this middle term 7. Okay, so I can make a list of factors of 12. 1 times 12, 2 times 6, 3 times 4. The ones that have a sum of 7 are these last two. So 1 plus 12 is 13, that's not good. 2 plus 6 is 8, close but not quite. 3 plus 4 is 7, there it is. Okay, wait, now what? Remember what to do? Once you come up with these two numbers, this is this split up the middle term part of the problem. So we're going to take that 7x and rewrite it as 3x plus 4x. Okay, the reality is we could actually write it in another order. That would be okay. It would look a little different along the way, but the final answer would still turn out to be the same. Okay, so when you're doing the splitting up part here, it doesn't matter which number you write first. In fact, you might be looking at this saying, I wish I could put the 3x with the 6 and the 4x with the 2. It feels like those match up better. That would be just fine. I'm going to leave it this way. It will work out regardless. Okay, so now I get to bring down the other terms. So the 2x squared comes down, plus 3x plus 4x, and then the 6 also comes down. So from here to the end, now I get to do grouping, because now we have 4 terms. Okay, so grouping. That's a good little review. Oh my goodness. Having some handwriting issues today. Grouping is what I tried to write. All right, go ahead and start grouping. So split up your terms into 2 groups of 2. Like this, okay. 2x squared plus 3x, that's my first group. 4x plus 6, that's my second group. Let's start with the first group. The GCF, or greatest common factor, is just x. When I factor that out, then I'm left with 2x plus 3. Moving on to my second group, 4x plus 6, the GCF there is 2. So I'll write plus 2. And I factor out a 2 from each of those. 4x divided by 2 would be 2x. 6 divided by 2 would be 3. And here we are. So we have x, parentheses, 2x plus 3, and then plus 2, parentheses, 2x plus 3. Remember, to finish a grouping problem, what's in the parentheses should be the same for both. So you'll rewrite that factor. It's kind of like another GCF in a way. It's common, it's appearing twice. 2x plus 3. And then sort of those leftover outside terms, there's an x, and then there's a plus 2. So that goes next in my parentheses. So my final answer is 2x plus 3 times x plus 2. Okay, and if I go back, I'm going to go back a couple slides here. There it is. Remember when we did this same problem using trial and error, totally different method, 2x squared plus 7x plus 6, but we still ended up getting the same answer. Oh, and that's the one I wrote on the whiteboard. Never mind. Okay. Sorry, everybody. Taking you all over the place. Here's what I meant to show you. Okay. Here's what we had gotten with that same problem. We ended up getting 2x plus 3 times x plus 2. I just wanted you to see the answer was the same. That's all. Okay. Back we go. Okay. Let's see. So I think that's where I will end part 1 of our, what are we on? Lesson 27 of our lesson 27 video. So that's a lot. You've now been introduced to 2 different methods of factoring trinomials where there's a leading coefficient other than 1. You might now have an opinion or a feeling about which method you prefer. In part 2, in just a few minutes, we're going to continue with some slightly harder examples, and we will see both methods coming in handy, both methods being used. So if you feel like you already have a preference, that's fine. Just know that it will be to your benefit to be able to do both. All right, so we've made it through examples 1, 2, 3, and 4. We've seen 2 trial and error problems, 2 AC method problems, and then I'm going to end the video here. That's part 1. It's like we're in the middle of class. Take a break, take a stretch, whatever you need. And then a few minutes later, come right back. And then you can watch part 2 and we'll pick up where we left off. All right. See you soon.